Hi guys, so let's look at the August 2020 paper 1 for Khomas. This is for matric mathematics. Okay, so here we have our instructions, all the normal instructions. For diagrams, use a soft pencil. They give us the number of marks and brackets at the end. And if we want to work out something with pi, we can either use pi on the calculator or we can use 3.142. And the important part that we need to take note of is if the degree of accuracy is not specified in the question, and if the answer is not exact, give the answer to 3 significant figures. Okay. Or give the answers for any angle to 1 decimal place. So this is what we have to take into account if they don't tell us exactly what they want in the question itself. Yeah, let's start with question 1. Okay, so here we have a question that says paint is sold in cylindrical tins of height 11 centimeters. Each tin holds 750 ml of paint and costs $57.20. So a profit of 30% is included in this retail price. Okay, so here we have to keep our heads a little bit. So we know this is the retail price according to this question. And this already includes a 30% markup on what the initial cost price was. So now we need to find out what was the initial cost price of the tin of paint. Alright, so to do that we can do this in a couple of ways. When I was at school I used to like the algebraic formulation of this question. So I would say initially the tin cost X dollars. And then we added to that another 30% of the original price. So 30% is the same as 0.3, right? 30 over 100. So add to that 30% of X, and that gives us our new value of 57.2. And then we just solve for X from here. So 1X plus 0.3X is 1.3X. And that equals 57.2. And then we can just divide both sides by 1.3 to solve for X. Okay, so then we get X equals, and we have to remember to put our units. In this case, they already given us the units, so that's fine. And in this case, it's actually not Namibian dollars, it's just dollars. Okay, so let's rip out the calculator and see what we get here. So this gives us, let me just clear everything here. Okay, so that's all clear. We get 57.2, and we divide that by 1.3. which gives us $44. Okay, so that is our answer here, 44. Now, we can also, let's just do it another way. So we could also do this by the way that most people would probably do it, and that's just using some shortcut formulas for calculating prices. And this is called the reverse percentages, because we're trying to find what the original was. Okay, so what the best way to not get confused by doing this I found is to write the thing we want in the top left. So we want the original price, and original is always 100%, right? So from the original 100%, we either add or subtract some percentage to get the new price. Okay, so we want the 100, so we put it in the top left, and then to this 100 we added 30%. So we add 30 to the 100, and then we just multiply that by our new value, which is 57.2 in this case. And then again, we can just type that on our calculator. So we can say 100 over 130 multiplied by 57.2. And we see that gives us 44. And that is the same answer. Good. Okay, so that was the first question. Now the second question, tins are filled at a rate of 2 cubic meters per minute. How many 750 ml tins can be filled in 1 hour? Okay, so let's see what we need to do. So we see here we've got a cubic meter sort of a unit here, and we've got a milliliter. So we've got a cubic distance and a milliliter type of thing. So we need to convert one of these into the other. So what I'm going to do is I think I'm going to convert the cubic meters into milliliters and work from there. So what we can do is we can say one of the things we should probably know is that 1 milliliter is equal to 1 cubic centimeter. So that is a nice one to, oopsie. So that's a nice conversion to know. Alright, so what we want to do is convert the meters into millimeters, and then the millimeters, so we can convert, let me just rephrase that. we can convert cubic meters into cubic centimeters, and that'll be the same as the milliliters. Okay, so to get from meters to millimeters, let's just see here. So we've got meters, decimeters, centimeters, and millimeters. Okay, so we want to go from meters to centimeters. So that is 100. There's 100 centimeters in 1 meter, but we're working with cubic, so that's 3-dimensional. So for distance, it would just be 100. So let's do this. Let's do distance, it would be 100. For area, it would be 100 squared, because it's 2-dimensional. And then for volume, it'll be 100 cubed, because that's 3-dimensional. Alright, so from 2 meters, meters to cubic meters to cubic centimeters, we have to multiply by what? So we multiply by 100 cubed. So times 100 cubed. The 100 cubed is just 100 times another 100 times another 100. That's 1, 2, 3, 4, 5, 6 zeros. So that's 2 with 6 zeros. Okay, so that's centimeters cubed, and we see centimeters cubed is equal to milliliters. So we have 2000 milliliters, and we want to divide that by 750 milliliters to find out how many milliliters, how many tins can be filled in 1 minute. Okay, so let's see what the calculator gives us for that. So we're going to do 2 million 3, 4, 5, 6 divided by 750 mil. So that gives us this whole thing, 266 and 2/3. So 266 and 2/3. So tins. That's how many tins per minute. But we want to do per hour. So how many minutes are there an hour? 60. So we're just going to have to say multiply this by 60, and that'll give us the number of things per hour. So let's just type that times 60, and we get 160,000. So that's 160, 1, 2, 3. 160,000 tins can be filled in 1 hour. Okay. Question C. Calculate the radius of the tin, giving your answer to 1 decimal place. Okay, so let's draw the tin first. So for the tin, it's a cylindrical tin, and my drawing skills are not very good, but hopefully it'll be good enough to at least get an idea of what we're doing. Okay, so we want to find this radius. We know the height is 11, and to calculate the volume of a cylinder, or actually of any prism, we take the base area, so base area or area of base, and multiply that by the height, or the 3rd dimension of our shape. Base area and height. So the base area, this will be our base area in this case, and then we multiply that by the height. So the base is a circle, area of a circle is pi radius squared. And we want to multiply that by the height, which is 11, and we know that gives us 750 milliliters, which is also 750 cubic centimeters. Okay, and since this 11 is already in centimeters, we don't have to do any other conversions. Now we can just solve for r. So we want to get r by itself. First thing we can do is we can divide both sides by 11 pi. And that'll give us r squared is equal to the 750 over 11 pi. And then to get the r by itself completely, we just take the square root of both sides. And that'll give us r equals the square root of this. So let's work that out. Okay, so that'll give us the square root of 750 divided by 11 pi. 11 pi. Okay, maybe just to be sure, let's just put some more brackets around here. And that gives us 4.6. And we need what? 1 decimal place. So that gives us 4.7. So that's 4.7 centimeters. Let me just write down this whole thing here in this spot. And then we can see we'll just round that off. Okay, so that's our radius, and then rounding it off to 1 decimal place. And then if you want to check your answer, that's the nice thing about mathematics, you can almost always check your answer. So we can work out what is pi. Let's just write this here, check our answer. So we've got pi times our radius squared times our height. And let's see what that gives us. And since it's rounded off, it'll be out by a little bit. But okay, let's actually use the full answer here before we round off. That should be pretty close to the correct answer then. So we want pi, where's pi? Pi times that squared times 11. And we see that gives us 750. So our answer is correct. That gives us 750. Nice. All right, question D. So that'll be the last question for last part for question 1. A mathematically similar tin. Okay, what does that mean? Mathematically similar means if we make the tin larger or smaller, all the parts of it goes larger or smaller by sort of the same ratio, right? And so let me show that by just drawing a square, and we can see. So this square, to make it mathematically similar, if we enlarge it like this, we see all the different dimensions. So the length and the width, they increase by the same ratio. When we make it smaller, so we see the shape stays mathematically similar. It means it's got the same ratio of dimensions. All right. Now, something to look at is if we've got, whoa, still drawing squares, my bad. We've got a length, an area, and a volume component to think about in any 3D shape. So let's do shape A and shape B. So if shape A, if the ratio is 1 to 2, well, let's make it slightly better. Let's make it 2 to 3. Right, 2 to 3. If the ratio is 2 to 3, and we can do this, let's actually do it with a bit of an example. Actually, that's fine. Let's do one a little bit bigger. Yeah, I'm sorry if this takes a little bit long, but I think it would be useful to do this. And copy and paste this one. I'm just going to draw a couple of 3D shapes here. Let's just connect those, and a little dotted line here. So dotted line, and we connect these other edges. Okay, so now we've got 2 cubes. So if this length here is 2 and 2 and 2, and this one is 3 and 3 and 3. Okay, so we see here our length is 2 to 3. But what about the area? Let's pick the front area here. So what is the ratio of that area to that area? Well, this area will be length times breadth, so that's 2 times 2, which is 4. And this area is 3 times 3, which is 9. And then if we do the volume, so the whole volume of the shapes, volume of a cube we know is 2 times 2 times 2, so that's 8. And same here, 3 times 3 times 3, which is 27. So what we've noticed is for area we just square, and for volume we cube the ratios of the lengths. Okay, so this one we can say the area is also 2 squared to 3 squared, and for the volume we've got 2 cubed to 3 cubed. So we see that's the important thing to take into account here. So length to area to volume, we just add an exponent each time. 2 to the power 1, 2 squared, 2 cubed. 3 to the power 1, 3 squared, 3 cubed. And we want to make use of this in this question. Okay, so mathematically similar tin holds 6 liters of paint. Okay, so we're going to do the length, area, and volume again. So we've got our smaller tin, and the smaller, yeah, let's call it the 750 ml tin, and we've got the 6,000 ml tin, 6 liters, right? Okay, and well, that's the volume. We can put that at volume. I'm just going to drag that down to volume. So that's the ratio of the volumes of these 2 tins. And so we can find out the ratio of the lengths and the areas as well. So to get from volume to length, we see we have to take the cube root, right? So in this case we had 8 to 27, so that means the length would be 2 to 3, because that's the cube root of 27 and the cube root of 8. So we have to take the cube root of 750, cube root, and the cube root of 6000. So that's the ratio of the lengths. And then to get the area, what did we say? We square the ratio of the lengths. So we're going to take this whole thing, the 750, the cube root of 750, and just square that. And then we're going to take the cube root of 6000, and we're going to square that. Okay, so now we have the ratios of the lengths, the areas, and the volume. So let's see what they ask. Okay, the label on the 750 ml tin has an area of 280. Okay, so we're working with the area one, it looks like. Calculate the area of the label on this 6 liter tin. Okay, so this is our ratio. Let me move this ratio out of here. And we'll use this ratio to do the calculation. So that's the ratio of the areas, but the actual area of the 750 ml tin is 280. And the actual area of the 6000 milliliter tin is x. We don't know that. So let's call it x. And now the easy part here, we just cross multiply. So that times that equals that times that. Okay, now it looks like I'm running out of room a little bit here from doing this part. So I'm just going to erase this. I'm sure you can pause the video and go back if you want to check a look at that again, that explanation. So we're going to just do this whole calculation over here on the side and solve for x. Okay, so 280 times that, I'm just going to write that as 280 times the cube root of 6000 squared. Right, and that's going to be equal to that times x. So the cube root of 750 times x. And remember this square. Again, then we can just divide both sides by the cube root of 750 squared. And the same on this side, cube root of 750 squared. And that'll cancel out, so we only have x left. So that means x equals, now we can just type that whole thing on the calculator. And again, I'm sorry, my calculator doesn't look as nice as most of the calculators we use at school. Okay, so what we want to do is just type, is just type this whole part into the calculator. So I'm going to say the top part, we've got 280 multiplied by the cube root. And since I don't have a cube root on my calculator, I'm going to use exponents. I'm going to say that's times by 6000, which is raised to the power 2 over 3. 2 over 3. Okay, let's put that in brackets as well. So I'm going to have to make use of brackets quite nicely since I can't write fractions on this calculator. So that's the top part, and then we want to divide that by the bottom part, which we'll say is the cube root of 750. So again, I'm going to make this 750 raised to the power 2/3 as well. And we get 1120. What a nice number. Okay, so 1120, 1120, and write that down in the answer space provided. 1120. Okay, great. So that is it for question 1, and I'll upload question 2 as well shortly.